Welcome back to you all. In this lecture, we are going to talk about counters. In the previous lectures, we have discussed about register. Registers are an application of those flip-flops, and this counter is another very important application of flip-flops. So you must have heard about this term counter, and what you are expecting from anything which is named as counter. That has to count simply, no? So similarly, these circuits will also count. Okay, so whatever sequential circuits we are going to design, that will perform the operation of counting, and hence it is characterized as counter. Okay, so in the introduction part, there is few important definitions like a counter that follows the binary number sequence is called a binary counter. Mean it will count, it will start its counting from 0 0 0 0 0 1 0 1 0 like this. If you are counting from lower numbers to higher numbers, like if I have designed a circuit that can count from 0 to 15, that will be considered as up counter. And if it is particularly counting binary numbers, then it will be considered as binary up counter. If you are counting or you're designing the circuit and that is capable of counting from higher values to lower values, like first initially it is set to, let's say, 15, and then 14, 13, 12, then that will be considered as down counter. Okay, this numerator, don't bother about this. This is beyond the scope of our discussion. And let's say we are talking about n-bit binary counter. So for designing of n-bit binary counter, we need n number of flip-flops. Okay, furthermore, if I have taken, let's say, 3 flip-flops, so that will, with the help of those 3 flip-flops, we can design counters that will up count from 0 to 7, and total number of possible combinations will be, in that case, 8. Not actually combinations, total number of counts will be 8. Okay, and that will up count or down count from 0 to 7 or 7 to 0. Okay, now the types of counter, there is further characterization of types of counter, that is synchronous and asynchronous. So by synchronous we mean that each flip-flops what we are using will be connected with separate clock. Okay, in synchronous, all the flip-flops will be connected with a common clock. That will be more appropriate. All the flip-flops will be connected with a common clock. Okay, in asynchronous counter, you will provide clock to the first flip-flop. Okay, and the output of first flip-flop will be connected to the clock of next or second, and output of second flip-flop will be connected to the clock of third flip-flop, and so on. Is that clear? This is the difference between synchronous and asynchronous counters. So first we are going to talk about designing of asynchronous counter. There are a few important and basic steps. You should remember these. If you remember these steps, the designing of asynchronous counter is very easy. Okay, just follow the step. First you have to identify the mode of counter. Okay, how will you do that? For that we have got this formula: mode of counter should be less or equal to 2 raised power n, where n is representing the number of flip-flops required. Okay, so in the second step, let's say I have identified that I need n number of flip-flops to design any particular mode or counter. So I will take those number of flip-flops and I will connect the input of those flip-flops with the with O1. Okay, so in the third step, what we'll do, we'll provide clock to the first flip-flop, and the clock of other flip-flops won't be connected with this clock. What I have told you, the clock of these subsequent flip-flops will be connected with the previous output. So the clock of second flip-flop or first flip-flop will be connected to the clock. Okay, and the clock of second flip-flop will be connected to the output of first flip-flop, and so on. Okay, For example, in the next PPT, we'll discuss how to design a mod 16 counter. Okay, there is an important term mod. You may not have heard about that. So, mod defines the total number of counts in a counter. Okay, so if you are asked to design mod 16 counter, so that will up count from 0 to 15. Okay, and total number of counts in that case will be 16. Similarly, if you are asked to design mod 12 counter, what does it mean? It will up count from 0 to 11 and total number of counts will be 12. Please mind this difference.